This will be our introductory exploration of two-dimensional forces. Like all good vectors, the forces in two dimension have a horizontal component and a vertical component. So we will explore how to express the net forces for the horizontal and the net forces for the vertical. We've already discussed in one-dimensional motion that when there's an imbalance in opposing forces, the motion is in the direction of the larger of those two forces. Now in two-dimensional motion, we will write these net force equations to indicate that motion instead of having it be a separate problem. In this scenario, there is a positive 5 Newton force to the right and a negative 3 Newton force to the left. Because there's motion, we will set this net force equation equal to mass times acceleration, where the force is represented by the sum of all the horizontal forces. In this way, we can solve for the acceleration if we know the mass of the object that is moving. To reiterate a concept about action-reaction pairs, the force of gravity is the mass of an object times the gravitational attraction. The normal force is equal to the gravitational force, but in the opposite direction. In this particular scenario, the force of gravity and the normal force are the only forces acting in the vertical plane. When working net force problems, you have to determine if there is motion or if there is not motion, and it depends independently if it's horizontal or vertical. When there's motion, then the net force equation is set equal to mass times acceleration. When there is no motion in that plane, then we set it equal to 0 and then continue to solve accordingly. For instance, in this scenario, if the force of gravity on this mass is negative 100 newtons down, then the normal force would be positive 100 newtons up. If we wanted to draw the net force equation in the vertical, we would add all of these forces. So we have negative 100 newtons plus, positive 100 newtons for the normal force going up. And if in the problem we can determine that this object is not moving vertically, we would set that equal to 0. And that would be the net force in the vertical direction. But what to do if the force is being exerted at an angle? Well, like all good vectors, there is a horizontal and vertical component. To find the horizontal component of the force, we take the force times the cosine of the angle. For the vertical, we do F times the sine of the angle. We've used these equations before. Now we're going to apply them to forces. It's important to recognize the direction of the vectors when an object is pushed at an angle, like bending over to slide a crate across the floor, versus pulling an object at an angle. In this particular instance, it's being pushed. The force, the y force, or the y component of the force is downward, while the x component of the force is to the right. That's a positive direction. It's important to keep the direction straight when it comes to writing the net force equations. Here, I've gone ahead and drawn all the possible forces. And what we want to do is we want to write net force equations for the horizontal and a net force equation for the vertical. In the horizontal, we have to consider everything that is moving left or right. In this case, we have the horizontal component of force, which is F cosine theta, and there are no other forces right or left. However, the box is moving to the right, so we'll set this equal to ma. But it's important to remember not to use the value given for force, but to take the value of force times the cosine of the angle and use just the horizontal component. Now, looking at the sum of the forces in the y, it's a little more complicated, isn't it? So we've got the normal force pointing up. That's positive. We're going to add to that the force of gravity, which is down, so that's negative. And this component of the force, the y component, since the box is being pushed down and to the right, that is down, so we'll add a negative F sub y. Now the box is moving horizontally. It is not bouncing up and down. So for this net force equation in the y, we're going to set that equal to 0. From this, we should be able to answer any question that's being asked. Don't forget to find the y component of force, that's F sine theta. It's important to keep up with negative signs, meaning the down direction or the left direction. And then it's important to remember that the sum sign here, sigma, means sum of the forces. So everything is an addition problem, even though sometimes you're adding a negative value for one of the forces. Everything's about the same if you have an object that you're sliding. Let's say you're trying to pull a wagon with a handle at an angle. You just have to keep straight what direction the horizontal component of the force is going and the vertical component of the force is going. So our net sum equations come out a little differently, but not too much. So it's the same idea. We look in the x direction. What are all the forces in the x direction? Well, there's motion in the x direction, and there's the x component of force in the x direction, and that's it. The x component is a positive value because it's pulling to the right, and that'll be equal to the mass times the acceleration. The vertical component, we have the normal force going up plus the force of gravity going down plus the y component of the force also going up. Please just keep in mind, it's the sum of the forces, and those that go up are positive and those that go down are negative. When the force is at an angle, just pay attention. Is it going down or is it going up? And then decide what direction that means the components are going. Just like everything else we've done in physics, there is a system. For these problems, step 1 will be to draw that free body diagram, to draw all the forces that are involved. Step 2, if there is an angle, resolve the horizontal and vertical components of that. F cosine theta for horizontal, F sine theta for the vertical. And then just keep those off to the side. You're probably going to use them. Step 3 is to write the net force equations, first in the horizontal, then in the vertical. Typically the problems we're going to work involve something moving left or right, but having forces in both the horizontal and vertical planes. In this case, typically it's moving horizontally, so we set the sum of the x components equal to ma, and generally they're not jumping up and down, so we set the sum of the y forces or y components of the forces equal to 0. Then solve whatever question is being asked from there. You cannot solve these questions unless you can effectively write the net force equation. Spoiler alert, if the problem asks you to solve for acceleration, you'll be solving for the sum of the forces in the x, because typically these problems aren't talking about accelerating up or down. If the problem, however, asks for the normal force, which remember is the action-reaction pair with gravity, which is a vertical component force, then solve for the sum of the F sub y. I hope this video gets you on your way to solving these net force equation problems in 2 dimensions.